So whatever we have seen is low frequency response. See, remember in low frequency, high pass, ulta varo. Low frequency, you have high pass response. In high frequency, you will have low pass response. Okay, high frequency means where it is very, very large. After the mid-band frequency, the frequency is very, very large. So what happened? The frequency is very, very large. All the capacitance will act like short circuit. 1 by omega c. When omega equal to infinity, this capacitance will act like short circuit. Whatever input you give will go to ground. That is why the graph you see, the graph is reducing. The voltage gain starts reducing because the output is not available at the output or terminals of your transistor, but it is going to ground because of capacitors becoming short circuited. Because high frequency capacitors are short, at low frequency capacitors are open. So last circuit you see, when capacitor in series, resistance in shunt, you call it as a high pass circuit. Same thing, you reverse it. When resistance in series, capacitance in shunt, you call it as a low pass circuit. So this low pass circuit behavior is seen in the high frequency region of your transistor. Okay, this capacitor becomes short. So whatever input coming from the amplifier will go towards ground. So the output voltage starts decreasing at the output end. So that is, and you have a cutoff frequency FH. FH equal to 1 by 2 pi R2C2. So where it starts decreasing, that frequency is called as FH. So midband, we have seen in midband it is constant, completely constant. At one point it starts dropping. That point is called as upper 3 dB cutoff frequency. It is given by FH. So FH is also called as cutoff frequency or upper 3 dB cutoff frequency because it occurs in the high frequency region of the transistor. So when you, this is the frequency response of amplifier. So when you draw the frequency response, so you can see here from here to here the frequency gain is constant. So this is your mid frequency region. Below the less than mid frequency, it is your low frequency, and above the mid frequency you will have your high frequency, and you have the cutoff frequency FL and FH. And we define one term called as bandwidth. So bandwidth is given by FH minus FL. So the gain where the frequency where the gain is constant, so that frequency, that gain is called as the constant gain between the two frequencies FL and FH is called as bandwidth. So bandwidth equal to FH minus FL. The bandwidth is given as higher upper cutoff frequency minus lower cutoff frequency. What does bandwidth say to you? Bandwidth refers to the set of frequencies between which the gain is going to be constant. So on the frequency, if you're going to transmit your signal, you can have maximum amplification. If you're going to transmit the signal less than FL or more than FH, then the gain will be very, very less. So only in the mid frequency between FL and FH, the gain of the amplifier is maximum and it is equal to constant. Outside the mid frequency, the gain is going to be very, very less. So for any amplifier, two important parameters are gain and bandwidth. Gain can be voltage gain, power gain, or current gain, and bandwidth is the frequencies within which the gain becomes constant. So that is called as bandwidth. Okay, that is called as bandwidth. Any queries so far in today's class?